Let's now try to solve some questions together. Okay, so our main objective is going to be to solve problems related to elasticity and Hooke's law. This is our first worked example. An experiment is carried out to measure the extension of a rubber band for different loads. The results are shown below. So we have the load, we have the length of the spring for different loads. Then the corresponding extension for that load. They are all in centimeters here. There is a figure missing here, and you are asked to find what figure it is. Now, I will lead you through this example to come out with the answer. Now, for the unloaded spring, the length is 15.2 centimeters. So when the spring is not loaded, that's the load is 0, then the spring is free. So it will take its natural length, which is 15.2. There is no extension, so the extension 2 is 0. Now, it has now been extended by about 1 centimeter. So the total length will now be the original length plus the extension, giving us 16.2. Just pause for a moment and tell me what this value will be before you can continue. Alright, so your guess is as good as mine. We expect 17.3 centimeters to be the value here, because it has been extended by 2.1 centimeters. If you add this extension to the original length, we are going to get 17.3. Let's move on to the second question. A spring obeys Hooke's law. So we are first of all told that the spring obeys Hooke's law, which graph is obtained by plotting the extension of the spring against the load applied. So the extension against the load, they are all extension against the load. But which one explains or tells us about Hooke's law? For Hooke's law, we expect a straight line. For the same Hooke law, we expect the extension to be 0 when the load is also 0, and A is the best option. B cannot be, because it's telling us that no matter how much load we put on the spring will remain at the same extension. It will extend to a certain point and remain there, no matter how much load we put there. This one does not explain Hooke's law. See, this one too is not directly proportional. There is some curve in the graph. We expect a straight line in the graph for Hooke's law. Neither does this one also help us in any way. So A is the best option. Now, the example 3. Different weights are hung from a spring. So this is the unloaded spring. The first weight is 20 Newton, and it will change the length of the spring to 25 centimeters. There is another weight which we don't know. This time, if you attach it to the spring, it will change the length of the spring to 35 centimeters. We are expected to calculate the unknown weight. Alright. So we go back to Hooke's law again. The extension for 20 Newton is about 25 minus 15, which is 10. So if 20 Newton is causing an extension of 10, then what will be the weight that will cause an extension of 35 minus 15? That's 20 centimeters. Remember, there is proportionality between the force and the extension. There is proportionality. As you increase the force or the weight, there is a corresponding extension that are proportional. So if 20 Newton is causing an extension of 10 centimeters, then what weight will cause an extension of 20? Remember, realize that the extension has doubled, so we expect the weight to also double. W should be, your guess is as good as mine, 40 Newton. Let's move on to the fourth question. Here is a graph. That's extension load graph. We are going to answer a question on this graph. The unstretched length of the spring is 17.0 centimeters. If you don't stretch it, it will be 17.0 centimeters. This is extension load graph. So when it is not loaded, the extension will be 0. But if it were the length load graph, then it will start from 17. The extension will start from 17. It did not appear. There is another question that will show that. So when an object is hung from the spring, the length of the spring is 19.2 centimeters. What is the weight of the object? So we are being given length, and we are supposed to find the extension for these two lengths, the extension for the load, and translate it to the load that will cause that extension. The ticks here are not completed. So if this is 0 and this is 1, then we expect this one to be 2, 3, and 4. Now, you first have to calculate the extension before you can translate it onto this graph. You can't use these figures on the graph. Indeed, 19.2 is not even on this graph. So don't even think of locating 19.2 on this graph. You rather have to find the difference. That's the difference between the final length and the unloaded length, and that will be 2.2 centimeters. So you come here and you locate 2.2 centimeters on the extension axis. That will be this point. You read through and you get 3 Newton. That will be the weight for extending the spring to 19.2 centimeters. The fifth question is a graph that represents Hooke's law. You are expected to determine the label for this axis. Choose one from this list. So what do you think will be an appropriate label for the vertical axis? The horizontal axis is weight, which is the same as force or the load, and it is a straight line. So what do you think this one will be? A straight line starting from 0. So think about the confusion between the length of the spring and then the extension, the difference between them. And if this is starting from 0, then what will be the appropriate one? They are not using the terms we'll be using for the graph, but what you see here, one of them will actually represent the terms, the extension or the elongation or whatever. So if you really understand what we've spoken about so far, you will not find it difficult to realize that D is the best option. Then work the example 6. The diagram shows a steel spring and a graph of its length against the load applied to it. What is the extension of the spring when a load of 20 Newton is applied to it? A load of 20 Newton. Here we are. So we apply a load of 20 Newton to it. And where is the mouse? Here we are. And what we read here is, think about it, it's the length and it's not the extension. So 20 Newton will stretch the spring to 8 centimeters. The question is not asking you to tell us the length of the spring, it is telling us to find the extension. So if you want to find the extension, you need to know the current length and subtract the original length, the unstretched length. When the load is 0, what is the length of the spring? Determine the value here and then subtract it from 8 centimeters, and that will be your answer. I'm not telling you, work it out yourself and discuss on the platform.